Okay, so this first, they're all clearly a little more difficult than just the result of some easy rule. So we've got what? Undoing chain rule and undoing product rule. So what about this first one? And the first question we should always ask is it undoing chain rule? Is it undoing chain rule? Yes or no? Yes. Why? Because we have this interior function x squared, and essentially the derivative of it right there. So you can see that that's the result of chain rule. So we're going to look at this part and do what? Antiderivative of sine, keeping the inside as it is. We know we're almost done now, right? Antiderivative of sine is negative cosine. And so then we think, if we took the derivative of that, would we get exactly that? No. Right, so we would have it, when we do the chain rule, we'd have 2x, which we don't have 2x. So, yeah, you could do over 2, or we do negative 1/2, whatever. Done. Okay, next one. And so here's the thing about this. If you can just make something reasonable, that's a good attempt. Then what can you do? But you're not sure. Check it. How do you check it? Take the derivative. See, that this is all, but that's the whole point. The whole point of these is we're doing this thinking about what function has that as its derivative. So that's our whole mentality. What function has that as its derivative? So if we know we've got something close, take the derivative and then check it, see if it's the same. Okay? Next one. Is it undoing the chain rule? No, right? So the point is that the derivative of the interior function has to essentially be our other part, right? Like this is like our f and our f prime. Don't have that. So what do we got here? Can we do undoing the product rule? Yeah, so this is a classic example of undoing the product rule. X to some power times sine or cosine. Like we did cosine in class last time. So what we're going to do, we're going to have f and g prime. And what do we say to make f? We're going to make it x so that f prime reduces the power of x, right? Makes it easier. G prime then is sine 2x. So we got a little antiderivative to do here, and antiderivative of sine 2x is going to be negative 1/2 cosine 2x. Okay, and now we know that our answer, this is going to equal f times g minus integral f prime g. Remember, we're thinking of this as one term of a product rule, and instead so it'd be like f g prime, and we're gonna find the other term, and hopefully that's an easier integral, and then we just subtract that from both sides. All right, so we're gonna have x times negative 1/2 cosine 2x minus the integral of 1 times sine 2x. Nope, sorry, 1 times negative 1/2 cosine 2x. So this is the kind of thing you were doing for homework for today. And so is that the whole point? Is this a more manageable or doable antiderivative than what we started with? Yes, because it's just essentially cosine 2x. So coming down here, so our answer is going to be negative x over 2 cosine 2x. So we have minus makes plus, and then antiderivative of cosine is sine, so we're going to have a plus sine 2x, and we have a 1/2, but we're going to need another 1/2, right? We're going to need another 1/2 for this 2, so plus 1/4 plus c. So that one took that would have taken the most time on in the work you were doing because there's a process to go. So questions on that one? Do you follow? Okay, next one. So I'm gonna let's see. I need to make myself some room. So I'll do in red here. I'll do the next one in red. Next one. Always ask the question first. Does undoing the chain rule apply?
Yes.
It does, because we have this composite function, sine x squared, and look, we have the derivative of the interior function. That's always what we're looking for with undoing the chain rule. So first attempt is, so this is essentially sine to the -2. So first attempt will be sine to the -1. Because the derivative, and so what's the derivative? Negative sine to the -2 times cosine. Is that exactly what we have here? We also need a negative out here. So now when I take the derivative, -1 times -1, positive, sine to the -2 times the derivative, cosine is exactly what we started with, plus c. Questions on that one? Okay, so this is not undoing the chain rule, and we want to make one small change so that it is undoing the chain rule. What's one small change we can make so it is undoing the chain rule? Yes, sir? All right, so instead of t cubed, he wants just t to the first. Is that one way to do that? Yep, because t to the first is essentially the derivative of the inside function. Thinking about the result of a chain rule, right? The result of a chain rule is g prime f times f prime. So that's the pattern we're looking for, right? And so g prime f is like the square root, the square root in the denominator, 4 plus t squared. So we need the derivative of the interior function, to be our other term. So since this is t squared, we would need this to be t to the first. So one small change you can make would be change that to t to the first. And number 5, another way we could do it. Somebody new? Yes, sir? So instead of t squared, you want t to the 4th. Yep, if you made that one t to the 4th, now t to the t cubed is essentially the derivative of that interior function. So yeah, so either that's got to be a 1 or that's got to be a 4. And then you could undo the chain rule on this problem. Okay, you guys are being pretty quiet. Please ask a question if I lost you somewhere. Yes, sir. What's that? No, you would be changing the problem. So it's like, so you're making a change to the problem, right? So it's not that we're going to maintain that integral. We're actually making a new problem out of it so that it would apply. Does that make sense? Yeah. Yeah, right. So if I change that to t to the first, now it's not equal to what we had before. It's a new question. It's a new problem. It's not that one anymore. Same with changing the bottom from t squared to t to the 4th. Other questions? Yeah. No. No. Make one small change so that it applies. That's the question. No. Sorry, I hope that was clear. You didn't spend a lot of time doing that. What's that? This is I've been asking it in class though. It's the same question I've been asking in class. We're making, like, before we do this problem, let's make a small change so it's the same question I've been asking in class. So if you're ever not sure of something, please ask for clarification. Please raise your hand, ask for clarification. But it's the same question I've been asking in class. Okay, other questions? Okay, so let's actually do this one though. So the one that I was in number 4, it's not undoing the chain. We saw 2 ways you could change it to make it undoing the chain, but it's not. So how would we do it? What else do we got? So what else can we try? Undoing the product rule. Okay, so we got f g prime. Okay, let's just again here. Remember that f let's just review the premise of that. Nope. Okay, remember, so what are we doing when we do this undoing the product rule? Here's the product rule. The product of the derivative of a product is the first times the derivative of the second plus the second times the derivative of the first. And so if I was to take the antiderivative of both sides, I would have this, that just the original product would be the antiderivative of f g prime plus the antiderivative of g f prime. So that's just taking antiderivative of both sides. Remember, so our given problem is one of these. It's like this. And so we're going to try to figure out what f and g prime are so that the integral g f prime, the other term in the product rule, would be an easier antiderivative. And then we're really kind of never doing this antiderivative. We're never really doing this antiderivative except indirectly by doing a different one, by doing this one and knowing what fg is. We're just solving this equation for that, right? I didn't even touch anything. That's crazy. What happened? All right. Plan B. Oh. Okay. All right, so again, so we're not really ever doing this antiderivative. Instead, we're finding a different antiderivative and solving for this indirectly. So what will this equal? It'll equal fg minus that one. All right, so the one that we were given will be fg minus that one. So just keep that in mind as we're doing this. All right, so what was the one that we had here? What was that? T to the cubed? All right, so we're gonna figure out what f is and what g prime is. So what's one possibility? What can we do? Make f t cubed. That's kind of consistent with the things we've done before. And then what's g prime? 4 plus t squared to the negative 1/2. Okay, f prime is 3t squared. And so here's the question. We need to do the antiderivative of that. We need to do the antiderivative of that. Is that little antiderivative undoing the chain rule? What would we need for it to be undoing the chain rule? A t, right? So if this was times t, then we could do this little antiderivative as undoing the chain rule, but there's no t there. Is it a basic rule that we know? Something to the negative 4 plus t squared to the negative 1/2? No, it's the problem with, no, it's really not, because actually inverse sine is 1 minus t squared, but this is 4 plus t squared. Inverse tangent, but we've got to the negative 1/2, so there's a square root on it. So we can't really get this to work. So where do we go from here? Maybe we try the other way, right? So let's try f is 4 plus t squared to the minus 1/2, and g prime is t cubed. Well, we know we can take the derivative of that, so f prime is going to be negative 1/2 4 plus t squared to the negative 3/2 times 2t, right? And then g would be antiderivative of t cubed, 1/4 t to the 4th. So the question is the new, so we're going to say that our answer equals what? Fg, I'll just write Fg for now, minus antiderivative of what? Gf prime, 1/4 t to the 4th times negative 1/2 4 plus t squared, I'm getting nervous, to the negative 3/2 times 2t. And what was the point of this? That was supposed to be easier. Now we can make the t and the t4th t to the 5th, right? We can make the t and the t4th t to the 5th. But we have 4 plus t squared to the negative 3/2 and times t to the 5th. How did we do? Is it easier? No. It's like kind of like worse, right? It's kind of worse. It's kind of the same thing we had before, but instead of square root in the denominator, we have 3/2 in the denominator. Instead of t cubed, we have t to the 5th, which is not a match for 4 plus t squared in terms of undoing the chain rule. So it seemed like neither way worked. So, is it something else? Or any ideas? Yeah, but the quotient rule is what? So the quotient rule is what? Low d high minus high d low over low squared. So no, that's not anything like that. So there is something we can do if we're a little creative here. And it goes back to our first attempt. So I'm going to erase the second. The second attempt is definitely not right. This is bad, okay? But if we go back to that first attempt, that was actually more on the right track. We know it's not right because we don't have an easy antiderivative here to get that g. Remember we asked the question, what would we need in that g prime in order to do a little undoing the chain here for g prime to g? What would we need? We'd need a t. Okay, so that's the hint. If we had that times t, we could do the antiderivative and get g. Yeah.
Multiply t to the entire thing.
What do you mean the entire?
Multiply everything by t.
Well, then that's a new problem. It's a new problem. We have to, when we break this up, f and g prime has to be coming from this, right? So this is our problem, t cubed over square root of 4. So you can't just multiply by t, it changes the problem. I do over here.
What if instead of that being t cubed, that was t squared?
Okay.
And that other t was part of that?
Okay. So he's saying, what if we looked at this t cubed as t squared times t? Then what could we make f and g prime so this would work? F would be? So we'll do t squared for f and then times t for g prime. So now f times g prime is what we started with, right? Still t cubed over square root. So we're going to borrow, so we've got the t cubed and the f. We're going to just borrow one of those t's from the f and stick it on the g prime. So then it'll be t squared left, and then we can do it. See that trick? Pretty cool. And still the key is, are we going to get a doable a new antiderivative when we do this? So hopefully, right? Hopefully. Okay, did you get this? Agree with that? So as much as I've written, anybody have a question with as much as I've written so far? So the question is this easier, doable compared to the first one? Yes, because it is undoing the chain rule, right? Because we got 4 plus t squared. The derivative is in fact exactly 2t. So it's perfectly set up for us to do it as undoing the chain rule. So we got equals this minus. So it's going to be, so we're going to go with antiderivative of square root, right? Antiderivative of square root is 3/2. Now we got to clean up the mess here. So when we do the derivative, we're going to have 2t, but we also know when we do the derivative, we're going to have times 3/2. So what do we need? 2/3. So 3/2 times 2/3 goes away. 4 plus t squared to the 1/2 times 2t. There's the 2t. Got it. Questions on this one? Am I missing something? What? Oh, up there, g? Yeah, so you take the derivative, you get 1/2 to the negative 1/2 and then times 2t, so the times to 2t and the 1/2 go away. Yeah, so I think it's right. Yeah. So let's do the derivative of what I have written here, okay? Let's do the derivative of that, ready? Here we go. Derivative is 1/2 4 plus t squared to the negative 1/2 times 2t. 2 and 1/2 go away. So then you have that. You see it? Yeah. So yeah, that's the thing. If you can't see it, go ahead and write out the derivative. Write out the derivative and check it with what you started with. Okay, so let's talk about just in general common forms that you're on the lookout for undoing the product rule. So this is kind of a special problem. There's a kind of a list of just common forms that you should identify immediately as this new technique undoing the product rule. So let's talk about that. Okay, number one. So we saw like x to the n, a sine, say, kx, or cosine. So x to a power sine kx or cosine kx dx. What do we let f equal? We let it equal x to the n. Because then f prime will be 1 degree less and will be closer, or it'll be slightly easier. And we hope that n is not higher than 2, right? If it's 2, we got to do it twice, like at that example last time. If it's 3 or 4, for every number of that exponent is how many times you have to do undoing the product rule within the problem to finish it. Okay, so we hope this is a 1 or a 2 and no more. Okay, another one is similar to that is, say, x to the n e to the kx. That's another common form for this. And so again, f is going to be x to the n. Okay? In your homework, you had x to the n ln of x. Okay? So I would guess that you tried f equals x to the n to start. And then you ran into difficulty because if g prime is ln of x, what's the antiderivative of ln x? Who knows, right? Who knows? So in fact, this is different now. You have to make f equal to, you should have discovered that as you worked it out in those problems. Make f equal to ln x. And it doesn't matter what your power of x is, it will always take one step. You can always do it in one step, no matter if it's x to the 100 or x to the negative 5. When you work it out, f ln x, you can get it done in one step, no matter what your power of x is. Okay? Other common forms are inverse trig functions. So I was hoping to do this with you. We ran out of time, but for example, antiderivative of sine inverse x dx. Let's just get it started. So I want f and g prime. So what's going to be f and what's going to be g prime? Well, first of all, we only have one thing, right? So it's really like 1 times sine inverse of x. So first of all, you got to think of it that way. 1 times sine inverse of x. Now we have two things to work with. And so are we going to make f 1? Or are we going to make a sine inverse of x? If we make f 1 and we make g prime sine inverse of x, well, then what happens? We need to find the antiderivative of sine inverse of x. Well, that was the original problem we started with. You see? If you make g prime sine inverse, then this little teeny part of your problem is actually the whole problem you started with. So we've got to make f sine inverse. Because we know we can take the derivative of that. And so then we make g prime 1. We can take the derivative of sine inverse f prime. Antiderivative of 1 is easy. That is x. And you're off to the races, and you can do it. Okay, so these are what you're on the lookout for undoing product rule, the most common forms.